Welcome to Salford Science, the new set of learning materials developed for the teaching of varied subjects within the Computing, Science and Engineering Department of Salford University. In this current series, we will be looking at aviation and the many aspects that cover this wide subject in conjunction with the Aeronautics Department and wind tunnel testing facilities of the University of Salford. So in this episode, we will look at one of the most basic but important theories, drag. It is a relatively simple theory that has influenced most of today's high-speed jets, airliners, racing cars and many other crafts, and it is still a theory that is taken into great consideration in the creation of the latest British water speed record attempt with the Quicksilver project, being researched in conjunction with the university facilities. In this episode we will cover two main types of drag, form drag and skin friction. Form drag, also known as pressure drag, arises due to the form or shape of the object. The general size and shape of the body is the most important factor in form drag. As air flows around the body, the local velocity and pressure are changed. Since pressure is a measure of the momentum of the gas molecules and a change in momentum produces a force, a varying pressure distribution will produce a force on the body. The component of the aerodynamic force that is opposed to the motion is the drag. So, as you can see in the wind tunnel demonstration, the first two cars have a very streamlined body in comparison to this car. The vertical windscreen on this vehicle increases the drag as a direct result of the form of the vehicle. Skin friction. Another way we can think of drag is aerodynamic friction. When the molecules of the air and the solid surface of the aircraft interact, this causes what's known as skin friction. This type of drag is a direct interaction between the solid and the gas. With the solid, the best method of reducing skin friction is to have very smooth, solid waxed surfaces. The solid moving down the smooth surface is affected by drag, but by looking at the same solid on a textured surface, in this instance sandpaper, you can see the skin friction reduce the speed of the solid dependent on the surface area and texture. So applying this to a gas, the magnitude of the gas depends on the viscosity of the air and the relative magnitude of the viscous forces to the motion of the flow. These are expressed as the Reynolds number. Well, that's all we have time for in this episode. Next time we will continue looking at drag theory, but look in depth at induced drag.